Hello everyone, this is Karthikeyan. I am a candidate master on Code Forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals 2020 rank 27 and global rank 251 in Google Kickstart Round Day 2021. And today I am going to discuss the problem Mixi Game, which was asked in August Cook-Off 2018. The difficulty level of the problem is easy, the prerequisites are game theory and strategies, and the number of submissions this problem got in Division 1 were 290 and in Division 2 were 960. So now let's move on to the problem statement. Here is the problem statement. In this problem, we are given an expression asterisk of a1, asterisk of a2, and so on till asterisk of a of n. Here, this asterisk can either be plus or a minus. Okay, so if this asterisk is either assigned a plus or a minus, then this expression would look something like this. So either element is either considered as a positive element or as a negative element. Okay, so now let's read the problem statement. Given K and an array A consisting of n integers where each element of the array is greater than or equal to 0 and less than or equal to 1. Okay, now the element of the array is greater than or equal to 0 and less than or equal to 1. So there are two players, Vanja and Mixi. Vanja wants the absolute value of the expression. So this is the expression. Here for every asterisk we replace it with a plus or a minus. Okay. Now Vanja wants the absolute value of the expression to be greater than or equal to k, while Mixi wants to avoid that. They perform moves in turns. Assign a sign to the ith element. Vanja moves first. Okay. So basically we are having n elements, and to assign a sign to the odd element, basically the first element, third element, fifth element, seventh element, and so on, the 2x plus 1th element, Vanja is allowed to assign a sign to the 2x plus n 1th element. Whereas Mixi is allowed to assign a sign to the 2, 4th, 6th, 8th, 10th, so on till the 2x plus 2th element. Mixi is allowed to assign a sign. And Vanja wants the absolute value of the expression to be greater than or equal to k. So the absolute value of the expression v to be greater than or equal to k. And Mixi wants the absolute value of the expression, basically the sum of all the elements, plus of a1 minus of a2 plus of a3 minus of a4 or something like that, to be less than k. This is what they want. Now we have to tell that who wins the game, either Vanja or Mixi, if both of them play optimally. So this is a game theory problem. And Vanja wins the game if mod of v is greater than or equal to k, and Mixi wins the game if mod of v is less than k. So let's see what we would have done if we would have been Vanja or Mixi. Let's work on that. Now, if our value of our expression, the current value of our expression is s. Now, there are two cases. S is greater than 0 and another case is s is less than 0, and the third case is s is equal to 0. So in this case, for each case, let's devise the optimal move of each of the players, Vanja and Mixi. So the current value of the expression is s. So when it is positive, Vanja comes, Vanja has a turn. Now if you are Vanja, you want to maximize the value of the expression because you want the absolute value of the expression to be greater than or equal to k. So what would you do? You would consider the current element as a plus or a minus. You want to maximize the absolute value of the expression, and the current value of expression is positive. In order to increase the magnitude of this value, you will definitely consider the current element as positive. Okay, so Vanja's optimal move would be positive. Now let's come on to Mixi. So Mixi wants mod of v to be less than k. So if you are Mixi, the current value of the expression is positive and you does not want the absolute value of the expression to be greater than or equal to k. So you want to minimize that. So what would you do? Would you assign positive? Assigning it positive would increase the magnitude or increase the absolute value of the expression. No, so you won't do that. You would assign the current number as negative. So this is what Mixi would do when s is positive. So let's consider what Vanja and Mixi would do when s is negative. Here is Vanja. S is negative. Okay, So what Vanja wants? Vanja wants the absolute value of the expression to be greater than equal to k. If he or she assigns it as a positive number, then this particular value, assume that it is -5 and the next number 1 is assigned positive, it would be -4. So it would result in a decrease in the magnitude. But you as Vanja doesn't want that, because you want the magnitude to be greater than or equal to k. So you would definitely assign it as a negative number, the current number as negative. But if you are Mixi, what would you do? You have two options, positive and negative. You would definitely play opposite to that of Vanja. If the current value of the expression is -100, would you assign it -1? No, it would increase the magnitude, but you would assign it +1 because it would decrease the magnitude. So you go to play the positive card. Now, when s is 0, then it doesn't matter whether you assign it a positive or a negative, because in either of the cases, you assign a positive, it becomes a +1. You assign a negative, it becomes a -1. So the magnitude is same, and since the magnitude is same, this chance is neutral. Either you assign the current element as a positive or a negative. And the change in magnitude would only occur if the current element a of I is equal 1. A of I can also be equal 0. If it is equal to 0, then assigning it as positive or negative won't have any impact on the current magnitude, because adding a 0 or subtracting a 0 doesn't change the value v plus 0. V minus 0 is equal to v. That is a basic thing. Okay. So on this assumption, on this particular strategy, what strategy does Vanja has? If s is positive, Vanja would assign the current element positive. If s is negative, Vanja would assign the current element as negative. And this is the strategy for Vanja. What would be the strategy for Mixi? If s is positive, Mixi would assign the current element as negative in order to decrease the magnitude. If s is negative, Mixi would assign the current element as positive in order to decrease the magnitude. Okay, so we are clear about the strategies of Vanja and Mixi both. So what we would do, we are given n elements. The initial value of the expression is 0 when we haven't assigned a sign to any one of the elements. We would iterate from I equal to 1 till n and check either it is Vanja's turn if I is odd, or Mixi's turn if I is even. And depending on whose turn it is and the sign of s, we would either increase it by 1 or decrease it by 1 if a of I is equal 1. But if a of I is equal 0, we would simply continue, because assigning a 0 a positive sign or a negative sign doesn't has any effect on the magnitude. So let's solve it for this given test cases. So it is n and a k. So n is 2, k is 1, and this is the array 1 and 0. Okay. 1 and a 0, 2 and 1. So this is the value of k. Vanja has a chance. Currently s is equal to 0. First element incremented by 1. Make it 1. Mixi has a chance. 0. No effect. So who wins? Vanja wins the game. Now let's work on the second test case, which is 0, 1, 0, 3 and a 5. Initially the value of s is 0. Vanja has a chance. The value of the element is 0. Just continue. Mixi has a chance. The value of the element is 1, but s is 0. Either increase or decrease. Both of them are same. Just let's decrease. Vanja again has a chance. 0. Just continue. So what is the mod of this value? 1. It is less than 5. Who wins? Mixi wins. So we simply have to iterate from I equal to 1 till n and check if a of I is equal 0. We would simply continue, because either you assign a positive or negative, it won't have any impact. And if it is Vanja's chance and s is greater than 0, increment s. If it is Vanja's chance, I is odd, it is Vanja's chance, and s is less than 0, decrement it. If, yeah, here it should be an else if. It is Mixi's chance. I is an even. Even chances are for Mixi, and s is greater than 0. Simply decrement it. Else if it is Mixi's chance I is even, and S is less than or equal to 0, just increment it. For 0, you can either increment or decrement. Okay, so this is the code. This is the optimal approach, basically the strategy of both Vanja and Mixi. Vanja wants the magnitude to be as large as possible, whereas Mixi does not want to increase the magnitude, so they would play in that particular order. If S is positive, Vanja would want to increase the magnitude more, so she would assign the current element as positive. If S is negative, Vanja would want to increase the magnitude, assign the current element as negative. If S is positive, Mixi would assign the current element as negative, and if S is negative, Mixi would assign the current element as positive in order to decrease the magnitude. Okay, so let's move on to the code of this approach. Here is the code. Here T denotes the number of test cases. This is for fast input and output. N denotes the size of the array, or basically the number of elements in the array. K denotes the absolute value of the expression. If the absolute value of the expression is greater or equal to K, then Vanja wins, else Mixi wins. I take the input of the array. This is the sum. S denotes the current value of the expression. Now, if the current element is 0, okay, the current element is 0, no one makes a move because either you assign it a positive or a negative, doesn't have any effect, so just continue. But if I is even, so it's Vanja's move, because I was talking about 1 based indexing in my approach, but in the solution I have used 0 based indexing in order to explain you in a better manner. So if it is 0 based indexing, then for I being even, it is Vanja's turn. Now when it is Vanja's turn and the sum is positive, so Vanja would play a positive card, assign the current element as positive. It is 1 and increment S by 1. Else if it is Vanja's turn and the current element is less than or equal to 0, decrement the current element, increase the magnitude. Else if it is Mixi's turn and the current element is positive, decrease the magnitude, decrement the current element, S minus minus. Else if it is Mixi's turn and the current element is less than or equal to 0, plus plus. Basically, if it is less than 0, then plus 1 would result in decrease in the magnitude. If it is equal to 0, then basically it either you increase the element or decrease the element. If it is equal to 0, it would definitely have a magnitude of 1, because on increasing it would become a plus 1 and on decreasing it would become a minus 1. Now after iterating through this loop, check if the absolute value of S is greater than or equal to K. If it is greater than or equal to K, print 1, not Vanja. If you print Vanja here, it would be an error, so make sure that you print 1 here, because in most of the game theory problems, if there are two players, Alice and Bob, and Alice wins the match, you have to print Alice, and if Bob wins the match, you have to print Bob. But here you have to print 1 and 2, so that is an error you don't have to make, so just be sure about that. Else, if the absolute value of S is less than K, then mix evens and print 2. So this is the error that you might commit, so be sure that you don't do that. And also perform the operation when S is equal to 0. When S is equal to 0, you either increase the element or decrease the element. It won't have any impact, because on increasing the element on S equal to 0, it would become 1. On decreasing the element, it would become minus 1. So both of the positions are same, because here what we are considering the magnitude, and the magnitude in both the cases are same, which is 1. So you can see that the solution is accepted. So if you have any doubts regarding this approach, you can ask in the comment section. And thank you for watching the video.